Welcome dear students. Now we can think about the third intermediate, the third reactive intermediate, free radical. So what are free radicals? Free radicals are organic species which contain atom with an unpaired electron. Whenever there is an unpaired electron, we are called as free radical. So free radicals can be defined as any species which contain carbon atom with an unpaired electron. Okay, but it's not necessary that there should be always carbon. Even though some atoms like let it be chlorine, oxygen, okay, O dot, Cl dot, any atom, if it is existing as with unpaired electron, we can call it as free radical. So it is not particularly limited to carbon atom. It is for any other atom, any organic or inorganic atom which contain unpaired electron, we can call it as free radical. So that is a definition. Any species which contain an unpaired electron, any atom which contain an unpaired electron can be taken as a free radical. So we have examples like this, is it C dot, or we can have CH3 dot, CH2, CH3 dot. Similar to carbocations and carbanions, we have ethyl, methyl free radicals. Okay, so come to the preparation. How will you prepare free radical? So first of all definition, then example, after that we have preparation. So you know that free radicals are prepared by homolytic fission. Already we have discussed this in bond fission. So by homolytic cleavage, free radicals are produced. Okay, and for homolytic cleavage, the energy source, either it will be a thermal or photochemical. So preparation either by thermal homolytic cleavage or by photochemical, because for cleaving a bond homolytically we have to provide energy, either heat energy or light energy, thermal or photochemical. Okay, delta heat or photochemical light. These are the two ways for the preparation of free radicals. And let's be some simple examples we can have in your textbook. I think benzoyl peroxide is given. Let's just, since it is given in your textbook, I am representing here, but we can focus on some simple examples. Okay, C6H5CO, okay, benzoyl, then peroxide, OO, and easily this bond in presence of H nu or photochemical cleavage H nu, this bond homolytically cleaved. Okay, so what happened? You will get two molecules of C6H5CO dot, and when this benzoyl oxy radical easily undergo cleavage by the elimination of carbon dioxide, here also homolytic cleavage. Okay, first we have this homolytic cleavage, next here, then you will get 2 C6H5 dot plus 2 CO2. Okay, is it? So this is also an example, or you can have some simple examples like 2RCOCl, that is given in your note, like in presence of H nu you will get what, or RCOCl is enough, RCO dot plus Cl dot, is it? Or you can have some simple examples like chlorine Cl2, is it? Cl in presence of heat. Okay, heat, thermal cleavage, is it? In presence of heat, Cl dot plus Cl dot. So you can have any of this reaction as the method of preparation. Okay, then we can think about the structure, and structure means mainly we are explaining the hybridization, is it? Here carbon atom, both sp2 as well as sp3 hybridizations are possible. That means if it is sp2 hybridized, we know that it will be of similar to that of carbocation, and it will be like what, trigonal planar, is it? Trigonal planar, and there will be one unhybridized p orbital, and that unhybridized p orbital, unpaired electron is occupied by unhybridized p orbital. Okay, shape will be trigonal planar. Okay, but if we have this sp3 hybridization, then shape is like pyramidal, is it? As we have seen in the case of carbanions, is it? And since it is pyramidal shape, unpaired electron will be in one of the sp3 hybridized orbital. Okay, please listen. sp2 hybridization എന്ന് പറയുമ്പോൾ നമുക്ക് 3 ഓർബിറ്റൽസ് വരും, ഹൈബ്രിഡൈസ്ഡ് ആയിട്ടുള്ള 3 എണ്ണം വരും. പക്ഷെ ഒരു പി അൺഹൈബ്രിഡൈസ്ഡ് ആയിട്ട് നിൽക്കും കാണും. നമ്മളത് ഇവിടെ കാണിച്ചിരിക്കുന്നത് പി അൺഹൈബ്രിഡൈസ്ഡ് പിയിലായിരിക്കും അൺപെയ്ഡ് ഇലക്ട്രോൺ. അതേസമയം sp3 ആണെന്നുണ്ടെങ്കിൽ പിരമിഡൽ ഷേപ്പ് വരുന്നു. ആൻഡ് ദിസ് ക്യാൻ ബി possibly occur in one of the hybridized orbital. Okay, and in that way we can have sp3 hybridization also. Next we can think about the stability of free radicals. And first, stability by mesomeric effect, similar to carbocations and carbanions. First we can think about the stability by mesomeric effect. So if we have benzyl free radical, is it? If we have benzyl free radical, we can represent the structures. So whenever benzyl free radical is there, from benzyl free radical how we can generate? So please have a look here. This is the bond, is it? So this bond homolytically cleaved. Okay, so what happened? As a result, this bond homolytically cleaved. As a result, a new bond unpaired electron here and a new unpaired electron here also, is it? Here, but that forms a bond with this unpaired electron already exists, so it becomes CH2. Hope it's clear. Then we can have the next structure. Resonating structures we are representing by double head arrow, and here this one, okay, half hooked arrow, fish hook arrow, homolytic fission, is it? Then dot here, double bond here, because using this unpaired electron and new unpaired electron, double bond, then double bond CH2. Again what? Yeah, here this type of cleavage can be shown. Okay, as a result, here and bond here, is it? Double bond here, double bond CH2. And if we have the one more structure, you will get the first structure with CH2 with 1 2 3 4 5 fifth structure അങ്ങനെ ആയിരിക്കും, CH2 ലായിരിക്കും ഡോട്ട് വരുന്നത് അല്ലേ. So that will be same as first structure. So these are the 4 resonating structures of benzyl free radical. Similarly allyl അല്ലേ, നമ്മൾ ബെൻസൈലും അല്ലൈലും ആണ് മെസോമറിക് ഇഫക്റ്റ് വെച്ച് കാണിക്കുന്നത് അല്ലേ. ഓക്കെ, സോ ഇവിടെ എങ്ങനെ വരും നോക്കിയേ, ഹിയർ അല്ലേ, ദിസ് പൈ ബോണ്ട് ഹോമോലിറ്റിക് ക്ലീവേജ് കാണിച്ചിരിക്കും. ഇത് ഇത്രയും ഞാൻ കാണിച്ചതേ ഉള്ളൂ. ഓക്കെ, സോ യു വിൽ ഹാവ് CH2 ഡോട്ട്, ദെൻ പുതിയതും പഴയതും കൊണ്ട് ചേർന്നിട്ട്. So these are 2 compounds with the mesomeric effect, and these 2 will be highly stable, is it? Then similarly we have alkyl free radicals. Okay, CH3 dot, methyl free radical, ethyl free radical, isopropyl free radical, then what? Tertiary butyl free radical. Okay, and these also will be what are the stability order? Stability is due to inductive effect, mainly inductive effect, as well as hyperconjugation also you can take inductive effect. Okay, and stability order is methyl less than ethyl less than isopropyl less than tertiary butyl. That means this is primary. Ethyl means primary, secondary and tertiary. And you can compare this with carbocations, is it? കാർബോകാറ്റയോൺസിൻ്റെ സ്റ്റെബിലിറ്റി ഓർഡർ തന്നെയാണ്, കാർബോകാറ്റയോൺസിൻ്റെ അതേ സ്റ്റെബിലിറ്റി ഓർഡറാണ് ഫ്രീ റാഡിക്കൽസിനും. പ്ലീസ് റിമെമ്പർ, ഫ്രീ റാഡിക്കൽസിൻ്റെയും കാർബോകാറ്റയോൺസിൻ്റെ സ്റ്റെബിലിറ്റി ഓർഡർ സെയിം ആണ്. ടേർഷറി ഗ്രേറ്റർ ദാൻ സെക്കൻഡറി greater than primary. Okay, so tertiary greater than secondary greater than primary. So this is a stability order of free radicals, alkyl free radicals. Okay, so this much about intermediates. So please, dear students, go through these 3 videos and study well. Okay, thank you.